let's solve this question here. Okay. Now the question said, find the unit of viscosity. Find the unit of viscosity. The first step you have to take is to write down the formula, and after then we reduce the formula to its fundamental quantity. Okay. Now the formula for viscosity is force over area times velocity gradient. Okay. Now let's write down this formula step by step. Okay. The force is force, and the unit is kg meter per second square. Please take note of this. Okay. The next here is area. Area is length times breadth, and length is a meter times this breadth here can be classified under meter because it is not mass nor is it time. Please take note. Now for those confused, please, all you have to do is to watch the part 1 of this video before you can understand this particular solving. Okay. So the next is to express breadth is meter. Okay. Writing that we have meter. Okay, writing that we have meter. So we see that whenever we have any expression in two bases, that we use indices to evaluate that. Okay. Now we have this to be in two bases, that is m, and we have to take one and add up their powers. When you do that, we have this to be m raised power of 2. Please take note. So the next is velocity gradient. Velocity gradient. Okay. Now velocity gradient is equal to displacement over time. That is for velocity. Now the word gradient means that the formula or the quantity is divided by length. Please take note. Anything attached to gradient means that that particular formula is divided by length. So because of this word gradient here attached to velocity, I will divide the formula by length. Please take note. So the unit is this, meter per seconds over meter. So we know the unit of this, that is meter per seconds over meter. Okay. So when you do that, this is the same thing as this, as meter per seconds in a linear form over meter. So the meter here at the numerator, we divide the meter at the denominator. So our velocity gradient will be equal to per seconds. So we have known the unit of force, we have known the unit of area, and again we have known the unit of velocity gradient. So now let's impute the unit into this particular formula. Okay. So now let's impute the unit into this particular formula here. We have this to be viscosity eta is equal to kg meter per second squared over meter squared times per seconds. Please take note of that, okay? So let's simplify this class. Of course, there's meter at the numerator here and there's meter at the denominator. This will cancel this. When you do that, eta, that is the viscosity here, will be equal to class kg per second squared over meter per seconds. Now, there's something you have to understand here in terms of units. Please listen to me carefully. There's something you have to understand here in terms of units, that whenever you want to express the final answer of any unit at all, it must be expressed in a linear form. That means you have to take anything at denominator to numerator. So doing that, I have to take this guy here, that is our denominator to numerator. Remember, whenever you are taking anything from numerator to denominator, the sign of the power will change. So when you do that, class, when you do that, we have something like this. Eta is equal to kg. Taking this guy here, meter, from denominator, to numerator is going to be per meter. Now we already have per second squared. Now taking this one here from denominator to numerator is going to be times seconds. Of course, there's a law that whenever we have two bases, we take only one and add up their powers. These guys here are repeated, so we have to take only one and add up their powers. So this is going to be kg per meter. You take only one, you add up their power, that's minus 2 plus 1. There's an invisible one here. So I will have this to be kg per meter minus 2 plus 1 give us minus 1 per second. So this is our answer here. So all you have to do to get the next video on dimension, that is calculation on dimension, is to hit the subscriber button. Okay, thank you.